Good morning and good afternoon, and welcome to this video presentation. This is video number 4 in our 8-part series about, forces that automotive engines and automobiles overcome and have to overcome and utilize. And in this video, we're going to explore something that we kind of introduced in the previous video. For this one specifically, we're going to look at 4 cycles for power, and this focuses on the 4-cycle internal combustion engine. So, like I previously mentioned in the other video, if you haven't watched the other videos, make sure you watch those. However, for this video, make sure you at least watch video 3 so that you can understand some of the concepts that we'll go into here. Now, a part of video 3 was understanding the sequence of the different ways that energy is transformed in order for our vehicles to move. Now, we need to understand that the internal combustion engine, or an engine that combusts on the inside, which have been used for quite a while, even steam engines were kind of like combustion engines to a certain point. They had power and what have you, but they didn't actually combust. They just compressed air and then pushed air away, right? But the internal combustion engine actually requires 4 different things in effort to convert the energy from liquid fuels. All right, they require air, obviously the fuel, compression, and spark. All right, so here's the deal. All right, fire would not exist or cannot exist without oxygen. Oxygen is required to burn something. That's why when you have a candle and you put something over a candle, the candle will burn all the oxygen off, and that flame will start to diminish until it's completely gone. Why? Because all the oxygen has been removed. All right. Now, obviously, there's plenty of oxygen in our atmosphere. You know that our atmosphere is nitrogen and oxygen and some other parts of other stuff, right? But oxygen is a big portion of that, right? Now, when that air is inside of something, we can get, flame. All right, going back to that previous video that we saw in video 3 towards the end, you saw that when gasoline and air were added and you had the energy source from the fuel, you were able to ignite something, as they did there with their spark plug, right? Now, the fuel provides the source of potential energy. Why is it you can't use wood? Well, again, wood doesn't, although it burns with fire, okay, it can't really be manipulated and transported in streams and such in the way that fuels can, okay? So fuel provides the potential source of energy. Now, wood is a fuel for fire, so like in a campfire or a fireplace, or even in a steam engine, okay, where they use coal and wood, all right? Now, here's the key, all right? Internal combustion engines require compression. You see, as the piston moves up, it compresses that air and that fuel into a chamber, right? And as soon as that engine or that fuel is ignited, the energy release is much greater, okay? It's kind of like putting a firecracker, okay? If you ignite a firecracker and it's just in the air, yeah, it has an explosion and yeah, it has a sound to it, right? But if you take a firecracker and you bury it in a little bit of dirt and cover it, that explosion becomes a lot more because there's more energy being released, right? It's the same concept here, right? More compression equals more oxygen and more energy around that fuel. And then finally, the spark provides the fire to ignite the release of energy. Now, I will tell you that if you are ever working on an engine and it's an internal combustion engine, you want to make sure at minimum you have all of these items taken care of. All right. Again, the energy of the explosion is captured and then turned into mechanical energy. All right. And this happens during a single cycle. So let's go ahead and look at what I mean by those cycles. Okay. Smaller internal combustion engines, such as those found on, say, like RC cars that are gas-powered, some dirt bikes, some line trimmers, some four-wheelers, and small boats, right, use two-cycle engines, right? The piston goes up and down, and every time it goes up, it fires, right? It goes up for one cycle, down for another cycle, and then back up again, a total of 2 cycles. Now, in modern cars and in modern transportation, you might hear the term 4 cycles, all right? In other words, it takes 4 times, up 1, down 2, up 3, down 4, to make energy happen, all right? So those 4 cycles include what is called the intake stroke, right? As the piston moves down, it is pulling fuel and air mixture into its cylinder. Then, as the piston moves back up, there's that compression. We just talked about it, right? It squeezes the mixture and increases the amount of potential energy that you have, right? And then you have the combustion. In other words, when the spark plug ignites the fuel, the explosion forces that piston downward, right, for the 3rd cycle, and then as the piston comes back up again, it releases all of the expent gases and fuel and air and water and all the extra stuff that's left over after the combustion. And then it does it all over again. Kind of interesting, right? So let's take a look at a video about turning fuel into mechanical energy. And this is a kind of a neat one. It's one of my favorites.
Science, please!
Do the words auto mechanics make you curious? Actually, it's a cinch. A car is made up of wheels, seats, fuzzy dice, a body, and an engine. The internal combustion engine. The engine works in 4 stages. First, a valve opens and the piston lowers, letting a mixture of fuel and air into the combustion chamber. Second, as it comes up, the piston compresses the fuel-air mixture. Third, a spark from the spark plug ignites the mixture, which pushes the piston down again. Fourth, the exhaust valve opens and as it comes up, the piston pushes the spent gases out. And the cycle starts over again. Intake, compression, combustion, exhaust. Intake, compression, combustion, exhaust. Intake, compression, combustion, exhaust. Intake, compression, combustion, exhaust. The movement of the engine is transmitted to the wheels for the driver's delight.